All right, so these are the biggest telescopes in the world. The Keck telescope, there's actually two of them. They made twins, which is really cool. They decided to build these way back in the early 1990s, and they were going to cost a couple $100 million, and they went to the Keck Foundation, which is very wealthy. And they said, we want to build the biggest telescope in the world, we need this much money. And they said, okay, let's build two. So they built two twins of each other right here. Now you say, what's this? This is a laser. So what they do, and remember I told you the biggest challenge with telescopes nowadays is the atmosphere. The atmosphere will move the star images around and it'll make your stars fuzzy. And so it's better to be out in space. Well, you can't be out in space, but if you shoot a laser through the atmosphere, you can see how the laser gets bent by the atmosphere, and you can make your telescope do exactly the opposite and correct for that, which they did, and it was brilliant. And so they're making it act like it's in space by correcting for the atmospheric disturbance. It's kind of like noise-canceling headphones. You know, if you have noise-canceling headphones, it listens to the noise, and then it repeats it exactly out of phase, so it gets rid of the noise. Same thing here, it's just doing it with light. Okay? All right. Here's the Keck telescopes. Now they were interesting. Instead of making one giant mirror, what they did is they made a whole bunch of hexagonal mirrors. Each of these is about 6 feet across. Okay? And then they combine them all together. And then what they do is they shoot lasers off them continuously so that they can make them balance, match up exactly. Because it's not connected together, you have to keep the seams exactly perfect. So they bounce lasers off it and they can adjust where these meet up to the order of like 1/1,000,000th of a meter, so the thousandth of a millimeter. So they can keep it exactly in the right curvature no matter which way you bend the telescope around. Really super high-tech stuff. And it works fabulous. It's by far the best telescope in the world. This is a similar design telescope. This is not the one. This is the Hobby Eberly telescope. This is in McDonald Observatory, I told you, out in West Texas. It has a similar design where they have a whole bunch of hexagonal mirrors. Now what they did, theirs weren't as big. They're only about like this big, but they have a whole lot of them. And so the size across here is close to, it's not quite as big as the Keck telescope. It also has some issues where you can't actually image it because of the type of mount it has, but it works fabulous for spectroscopy. Now, the best telescope we had is almost defunct, the Hubble Space Telescope. This is it. It was launched in 1990. Okay? It was supposed to be launched in 1986. It was ready then. It was built in the 80s. But it wasn't launched until 1990 because, if you remember your history, the Challenger space shuttle blew up in 1986, just like 2 missions before they were going to launch the Space Telescope. And that shut down the program for about 3 or 4 years until 1990. And so once they got the shuttle up and running again, Hubble was one of the first things they put up there. They put it up there, they found out it was made wrong. They made a mistake. Remember when I told you have to grind this perfectly to focus to a focal point? Well, when they did this, they ground it, they made it it was the most perfect surface ever made on Earth, because it has to be perfect because there's no atmosphere, so you've got to make your mirror really, really good. They made a precise mirror, but to the wrong length. And so when everything came out, it was out of focus. And you're like, oh, well, how do you fix something up in space when there's a problem? Well, eventually they figured it out that the thing to do was to add lenses. Essentially, it's like people that have to wear glasses. It's like your lens can't focus quite precisely on your retina, so let's just add another lens that corrects for that. That's what they did with the Hubble Space Telescope. In 1993, the astronomers went up there, put in some repairs, changed a few things, and they got it working pretty much perfect. Since then, it has been by far, the most productive scientific experiment that NASA's ever done. We have learned more with the Hubble Space Telescope than with any other mission, and it's still going and it's still working now in 2020. They were hoping it would make it 10 years. We are pushing 30 years now of the Hubble Space Telescope. Now there's a problem, is the Hubble Space Telescope, to move it around and turn it, these are solar cells that make that work, but it has these gyroscopes in it. The gyroscopes keep it pointed and keep it figured out which way it's oriented in the sky. Well, over time, those gyroscopes wear out because they're spinning at 1,000 revolutions per minute, and after years and years of that, the bearings and stuff wear out. Well, they used to about every 3 to 5 years go up with the space shuttle and replace them and fix things in. So they've actually changed the cameras like 3 times and it's gotten better as it goes. But the problem is we don't have any space shuttle. We have no way to get to it, and there's no plans to get to it. So once the gyroscopes go out and they can't point it and use it anymore, it'll just be a big piece of junk floating up in space. But it has been fabulous. Best thing that ever happened to astronomers. Now they're replacing it with the James Webb Telescope, which is supposed to launch in 2015, then 2018, and then 2020. Last I heard, maybe 2021 or 2022. It's ready, they say, and it's in a warehouse. And that's supposed to replace it. It actually looks more in the infrared than the Hubble, but it's a much bigger telescope. All right. Here's more of the Hubble Space Telescope, showing you it with its mirror cover open. So it's a Cassegrain design. Light comes in, bounces off here, hits the secondary, goes back, and the instruments are back here that record all the data, and then it beams it back down to the Earth. Now it's not that big a telescope. It's only about 2 meters across. It's as big as they can make it and fit it in the Hubble in the space shuttle. Okay? It was designed to exactly fit in the space shuttle. In fact, they were worried if something went wrong and they couldn't get it out of the space shuttle, they couldn't land with it because it's too heavy. You could take off, but you couldn't land with it. But that didn't happen. They got it out. Everything worked well. So, all right. Good. End of this video, and we're going to talk about radio telescopes in the next one.